Welcome to solverfy.
So I wrote up top what we were given, where the power of the lens is -7 diopters. The distance to the object is 0.125 meters, which I converted from centimeters. And the height of the object, h0, is 1.0 millimeters here. Okay? So we can use equation 23-7 and 23-8 to find the image distance, and then we can use equation 23-9 to find the image height. So the image distance can be found using the equation 1 over distance to the object plus 1 over distance to the image is equal to 1 over the focal length. We don't know the focal length, but we know that 1 over the focal length is equal to the power, p, which we do know. Therefore, solving for the distance to the image, d sub I, we find that it is equal to d sub 0 divided by the power, p, times d sub 0 minus 1. So plugging those values above into this expression, we find that this is equal to -0.0667, and then the units here are meters. Okay, and because it's negative, we know that this is a virtual image and behind the lens. So we can go ahead and box all of that in as part of our answer to the question. Okay. The next part of our answer to the question has asked us to find the image height. So we can do that using the definition of magnification, where m, magnification, is equal to the image height divided by the object height, okay, which is equal to negative the distance to the image divided by the distance to the object. Okay, well, since we know the distance to the image and we know the distance to the object, since we just found the distance to the image and we're given the distance to the object, and we also know the height of the object, we can go ahead and find the height of the image. So the height of the image here is going to be equal to negative distance to the image divided by distance to the object times the height of the object, h0. So plugging those values into this expression, we can keep distance to the image and distance to the object in units of meters, since those units are going to cancel, and we'll keep the height of the object in units of millimeters, so our height of the image is also going to be in units of millimeters. And this comes out to equal 0.543 millimeters. Or excuse me, 0.534 millimeters. And since it's positive, this is upright. So we can go ahead and include that this is upright. And box that in as a second part of our solution to this question.